Welcome back to the deep dive. So today we're strapping in for a pretty deep descent into configuration management.
Which I know sounds a little dry.
It can sound dry, but it's actually the backbone of, efficient software development.
We're looking at a fascinating real-world problem from the Haskell programming world. You sent us some great sources on this. The sometimes agonizing process of modernizing a project's core documents.
Yeah, and this is a perfect example of how technical debt really shows up. We're focusing on the shift from one build tool, the traditional Cabal, to a format that plays nicely with newer tools like Stack.
Okay.
The goal here is moving all that project info from the old spalling.cabal file structure to the, much sleeker Hpack format inside a package.yaml file.
Okay, so let's set our mission for this deep dive. We need to understand why this shift is so important for modernization, but also, and this is the really cool part, how one developer solved a major tooling failure using a very creative, maybe a bit unconventional workaround.
With AI.
With AI, exactly. And we have to start with one essential technical point here, because if you're new to Haskell, this can be, confusing.
Right.
Hpack doesn't actually replace the .cabal file. It just supersedes how you create it. Think of Hpack's package.yaml as the blueprint, the clean, human-readable source of truth.
Okay.
Then you run the Hpack tool, it reads that blueprint, and it generates the complex .cabal file that the underlying tools, Cabal or Stack, they still need that file to actually run.
So Hpack just takes the cognitive load of managing that brittle .cabal file off your shoulders. It's a system manager for your system manager.
Precisely. It's all about automating the complexity.
Okay, let's set the stage a little bit historically for the sources you've got. Our listener, and I think a lot of developers, probably started their project with Cabal.
The traditional way, yeah.
And they moved to Stack, probably for better dependency management. And now they're at the final hurdle, aligning their project's metadata with what Stack expects.
That migration journey is so common. Cabal was the first standard, but it often led to what people call dependency hell.
Right.
And that's where Stack came in, bringing reproducibility and, frankly, sanity. But Stack works best when it has a clean configuration structure to rely on, which is Hpack.
The old .cabal files, they still work, but they're legacy. They're harder to maintain.
Now, in any normal technical migration, you expect there to be some nice, clean, automated conversion tool.
You would hope so.
So what was the official solution supposed to be?
The tool designed for this exact purpose. I mean, to lift all the data from the .cabal file and just drop it into a package.yaml. That was called Hpack convert.
That was the easy button.
That should have been the easy button. The one you press once and then you forget the old format ever existed.
Whether that would happen to our easy button.
Well, this is where the story gets, a little tense. The source author notes, pretty explicitly, that Hpack convert, it's just been abandoned.
Oh.
It's no longer maintained. And in today's environment, you often can't even get it to compile or run. Dependency rot. That's a huge failure point. You have this necessary transition for future maintainability, but the bridge you're supposed to take is just out.
It's gone.
And if you have a massive, complex project, translating 1,000 lines of config by hand is, it's not just tedious, you're guaranteed to make mistakes.
Oh, absolutely. Subtle, time-consuming errors. You're left with this big legacy.cabal file full of dependency lists, conditional flags, file paths, all this data you need to translate into a totally different hierarchical YAML format without breaking anything.
So since the direct path is closed, you have to get creative. You have to find another way across that chasm. And this is where modern tools really shine.
Right. The author realized the information in the legacy file was perfectly good, structurally sound. The problem wasn't the data, it was the format.
So they needed a tool that understood semantics, not just a fixed script.
Exactly. And this is a beautiful example of using technology for lateral thinking. They turned to artificial intelligence, a large language model, to bridge that gap left by the old, defunct tooling.
It's an efficient solution, and it's repeatable, even if it's not the traditional path.
The process they detailed is really just 3 steps. It's all built around preparation and then execution.
Walk us through those 3 steps.
Okay, step 1 is all preparation. You bootstrap a fresh, minimal project using Stack. This part is crucial.
Why is that so important?
Because it automatically generates a default, clean, and structurally correct package.yaml file for you. That file becomes your template, your guide. It guarantees the YAML syntax is valid from the get-go.
So you're making sure you have the right container before you pour in the old contents?
That's a perfect way to put it. Then, step 2, data extraction. You take your existing, fully populated .cabal file, the messy one, and you feed the entire text of it into an AI.
And step 3?
Step 3 is the conversion task. You prompt the AI to populate that new package.yaml template using only the information it just extracted from the old file.
Yeah.
You're basically tasking the model with mapping the two structures.
Mapping between Cabal's older, what
Yeah.
you'd call a domain-specific language, a DSL, and Hpack's YAML structure.
Exactly, and that's a great point to pause on. A DSL, like the .cabal format, is basically a mini language for one specific task, defining Haskell packages. It has its own syntax, its own keywords.
It's specialized.
Very specialized and often verbose and rigid. Hpack's YAML, on the other hand, is just a general-purpose, human-readable data format. The AI is brilliant here because it can interpret the intent of that specialized DSL and translate it into the general format. It bypasses the need for a brittle script.
Okay, but that brings up a risk. If we're relying on an LLM, how do you handle accuracy? A failed script throws an error. An AI could hallucinate a dependency, right? Or get a version number subtly wrong.
That is the critical difference, and you have to be aware of it. But in this scenario, the AI isn't creating new information. It's just doing a high-stakes, structured find and replace.
Nice.
The real key is the verification step, which comes later. But the speed and, frankly, the accuracy of this semantic mapping just far outweighs the manual effort if you have a good test suite to catch any mistakes. It really does act as a seamless bridge.
Okay, so let's assume the AI has done its job perfectly. Let's look at the result. What does this modern, cleaned-up package.yaml actually look like? The source gives an example for a project called Fish.
Yeah, and the Hpack file is an immediate visual upgrade. You start with the core metadata. The project is named Fish, version 0.1.0.0, licenses eGPL 3.0 or later, all standard YAML stuff.
But one piece of metadata really stands out as a sign of modernization, the language field.
Oh, absolutely. The source specifies the modern GHC 2024 language standard. This isn't just a version number, it's a huge quality of life improvement.
How so?
Well, instead of manually listing out dozens of individual language extensions in the .cabal file, things like overloaded strings, Type Applications GHC 2024 just bundles all the common stable extensions into one standard.
Ah, so it's huge simplification, a clear signal that this is a current, well-maintained project.
It saves pages of boilerplate. Then you get into how Hpack organizes dependencies, which is by scope. It's so much clearer. You have your global dependencies, like the standard base library, which apply to everything. Then it breaks the project into distinct components.
And what components did the Fish project have?
A pretty standard three-part setup. First, the library component. Its source directories are in .rc, and it has its own dependencies, like opt-parse applicative for command line parsing.
Okay, and the executable the user actually runs.
That's the executable component, named xs2book. The main file, main.hs, is in the app directory. And crucially, notice how GHC options are clearly scoped right here with it.
Ah, the runtime system options?
Right. Dethreaded IRSOPs and aliargas and with Thartons. These are essential for performance, for multi-threading. And Hpack makes sure those necessary, often confusing flags are applied consistently.
And the test.
Finally, you have the tests component, xs2ebook test. It pulls its source from the test directory and also gets those same standard GHC options applied. This clean, hierarchical structure is just so much easier to audit than the flat, repetitive .cabal file.
So after all this is translated and saved in the package.yaml, what's the final technical step to make it all work?
You have to trigger the generation of the legacy file.
Yeah.
The source notes they used Hpack version 2.38.3, and the command is simple. You just run docpack force. That reads your beautiful clean YAML and regenerates the .cabal file for Stack and Cabal to use.
So we solved the conversion problem with a clever AI trick. But what's the actual lasting payoff? Why was all that effort worth it beyond just having a YAML file?
The payoff comes in two big forms. One is just a massive quality of life improvement and readability, and the other is fundamentally better, safer code through more rigorous enforcement.
Let's start with readability. I mean, config errors often happen when you're just scanning a file too quickly. How does Hpack fix that?
The difference is striking. Old Cabal files, they often used a lot of horizontal padding, extra spaces, to try and line things up.
Which never quite works, does it?
It makes it harder to read. It was a visual nightmare, especially with long dependency lists. Hpack, because it uses YAML best practices, enforces vertical alignment. It moves values to new lines.
So it's all just clean, indented blocks.
Exactly. You end up with these highly scannable blocks. If you need to add a dependency or check a flag, your eye just moves cleanly down the list. It really reduces the chance of misreading a scope or missing a detail. That adds up over the life of a project.
That's a great administrative benefit. But the second part you mentioned, the rigorous code safety, that sounds like the real prize.
Yeah.
You said older setups just had the basic show-all compiler warnings. How big of an upgrade are we really talking about?
We're moving from a routine checkup to a full MRI scan. The wall is great. It catches the obvious stuff, unused variables, things like that. But it doesn't catch subtle, more subjective errors. The Hpack and Stack migration enforces a set of GHC options that is a serious safety net. It forces you to write code that is demonstrably safer and more modern.
Can you give us an example? What does that safety net actually prevent?
Sure, take the flag when complete record updates. This flag warns you if you're updating only some fields of a record, leaving others potentially undefined or with old values. That kind of bug in production could cause some really weird runtime behavior.
Or just crash.
By enforcing these stricter flags, Hpack is shifting potential runtime errors back into compile time warnings.
Which is where you want them. So instead of a customer finding the bug, the compiler yells at you immediately.
Exactly. And the source lists a whole suite of these valuable flags that came with the Hpack structure. Things like dapio-compat for backward compatibility, identities.
What about structural issues?
You get warnings for those, too. When complete unipatterns catches non-exhaustive pattern matches, notorious for causing crashes. You also get checks for module organization, like Dwarga's missing export lists and Wasing home modules. They encourage discipline.
And flags that police redundancy.
Yes, specifically Dwarga's partial fields and Warga's redundant constraints. It's a comprehensive upgrade in code quality enforcement that you get, basically for free, just by migrating your config to Hpack. The AI workaround is your ticket to this level of rigor.
Which makes the conversion totally worth it. But since you use an AI, the final step isn't just running Hpack, is it? You have to verify everything.
That verification step is absolutely non-negotiable, especially after using a non-traditional method. The author correctly emphasizes this. You have to test the result with both systems.
So you run the whole tool chain.
The whole thing. First, stack build, stack run, stack test. That all passes. You then make sure the legacy system still understands the generated file. A Cabal build, Cabal run, Cabal test. Only when both tools agree that the project is sound is the migration truly done.
This deep dive has really highlighted a crucial lesson in tech infrastructure, Modernization often means finding creative solutions when the tools you expect to be there just fail.
Definitely. We saw a broken utility, a clever fix using AI semantic mapping, and a huge payoff in better code quality and a cleaner project structure.
The fundamental takeaway seems to be that the knowledge is the asset. That old .cabal file was a rich source of data. The ingenuity was just finding a tool that could liberate that data and put it into a format Hpack that supports modern, rigorous development.
Right. It's about not letting the format dictate the pace of your progress.
It really makes you think about how intricate configuration management is, even for personal projects. The author of our source material maintains not only these Haskell notes, but also detailed logs on completely unrelated topics.
Like fish keeping and gardening. An amazingly diverse and apparently highly structured knowledge portfolio.
Well, if managing the config for a simple Haskell utility requires an AI workaround just to keep dependency lists clean and compiler flags strict, it begs a final thought for you to ponder. Okay.
The author keeps a large-scale beta spawn log. It details breeding schedules, tank parameters, all these environmental variables. So, what complex, unseen configuration challenges exist in maintaining that kind of highly detailed, non-digital data?
Yeah.
I mean, is there an equally frustrating legacy format or deprecated system, maybe a specific notebook type that's out of print or a charting method that could sabotage the long-term maintenance of crucial fish breeding results, requiring an equally creative fix?
That's fascinating. The need for clear structure and rigorous integrity testing, like those compiler flags, suddenly applies to every system that captures knowledge. What if the integrity of your spawn log depends on finding a tool that can translate handwritten data into modern standards?
We'll leave you to consider the YAML requirements of your next high-stakes data structure. We'll see you next time for another deep dive.